it take to actually go live part to this that you always see at the start of these Nuts IoT meetups. But essentially, thank you very much for coming along to Nuts IoT. We've got some new people here as well tonight, which is awesome. So thank you to you folks for coming along. If I can get my slides to actually go, we have got a code of conduct. There's a lot of words on this screen, but really it just boils down to this part in the bottom right here. Be kind and considerate. If you feel like that's not the case, then just send me a direct message in the Zoom chat, and I'll endeavour to put that right for you. But generally, we have nice people at these meetings, so it's not expected to be a problem. We're sponsored tonight by JetBrains, and essentially my consultancy is still running in the background, although I'm working for Avanade, and that's my primary job. That kind of sits in the background, pays for all of the web hosting and all of that sort of stuff. So that's why that's there. For JetBrains, if you don't know what they do, they make developer tools for developers. So things like ReSharper, WebStorm, PHP Storm, PyTorch, all of those different sorts of things, PyCharm, all that sort of stuff rather. So they've very kindly donated any one of their products with a 12-month license. So if you tweet on the hashtag NotsIoT, then I'll randomly draw a person to win one of those licenses. Even if you've already got one, by all means take it and give it away to somebody else. That's still a valid thing to do. So do check that out. I'm a Microsoft MVP, so if you've not heard what that is, if you run community meetups like this or speak at events like Simon's doing, or you're contributing to open source or producing blogs and podcasts around the Microsoft ecosystem, then if you do enough of that and you become recognized, they'll award you with this MVP, which gives you direct access to their product groups and drive the direction of product in Microsoft, and also a few other benefits on top of that. If that's something that's interesting to you, then come and speak to me and I'll happily guide you along with that. Tonight, we've got Simon Prickett talking about Raspberry Pi sensors and CrateDB, so can't wait for that. We don't currently have, and maybe Mehul will help with this, a speaker for next month. I've not sorted that out. I've just run out of time. Hopefully we'll sort that one out. But we do have a Lati meetup. So this is an in-person technical user group that I run in Loughborough specifically. This is the third in a set of new sessions that we're running, where the first one we had a bunch of content around innovation and investment in Loughborough with the Labour MP and the head of growth at the council. Yesterday, in fact, we had robotics and automation. We had a couple of great talks from a couple of folks there around robotics and simulation, emulation, and all that sort of stuff. And then on the 13th of November, we've got Mike Pound. If you've ever been on Numberphile, you'll see that guy on there. He's a Nottingham University lecturer, really good speaker. And Firat Matmaz, I think it's Batmaz actually. I'm not quite sure why it says Batmaz. I should say Batmaz, apologies. From Loughborough University, we'll be talking in and around the topics I've listed there. We yet to pin him down for a talk on that, but that's likely going to be very good as well. And with that, that's enough for me. I will stop sharing and then yep, then you can switch over to Simon and let you start. Now we normally just have everybody mute during Simon's talk and then just put your questions in the chat and then I'll interrupt Simon as we go. But then at the end, then everyone come off mute again and we can ask questions that way. By all means, if you're on camera, stay on camera. If you're not on camera and you want to come on camera, by all means do. Don't necessarily need to. Entirely up to you. But we find the speaker likes it a little bit better. So there you go.
Right. So hopefully we can see some slides.
I can indeed.
Excellent. Because one of the things with Zoom is once you start screen sharing, your world goes into this sort of black hole of I don't really know what's going on. So if at any point I'm talking about something and you can't see it, please do
just for your benefit, we can see the crib note slide rather than just the slide. So it's the one for yourself to view.
That's no good.
You beat me to it, and thank you, Mehul.
That's better then.
It will be. It's still the same for me at the minute.
Oh, I need to hit the share button. That's better.
Ah, that's the one. Great stuff.
I am very used to using StreamYard, which is a whole different animal for doing things. Okay, so yeah, we are here today at Knox IoT, and thanks to Pete for inviting me. I'm going to talk about Raspberry Pi, mostly the Pico devices, but a little bit the sort of larger devices. Why do we talk about the Pico devices a lot? Because recently there's been a lot of supply chain issues with getting regular Raspberry Pis. So Pico devices have become interesting for a number of reasons. They are really cheap, they have Wi-Fi, and you can run MicroPython on them, which means you don't have to go and learn C. Learning C is not a bad thing, but it is a thing that's a barrier to quick adoption and certainly quick just fiddling with things. C has a sort of learn it, compile, run, see what happens cycle. There's minimal debugging on these little microprocessors, so that's a lot more painful than a Python cycle of open up some sort of REPL, type some code, and immediately see what happens. A light comes on or some results come out. So let's see if we can click in the right place and advance that. So who am I? I'm Simon. What am I doing here? I do believe in declaring your biases. So this is my job. I am a developer relations professional, and I work for CrateDB, which is a database product, and we'll talk about that in a moment. I'm not as such here to sell you anything. It's an open source database product, so you can grab it and play around with it entirely on your own, or you can use our cloud, and we'll come to that later. If you want to find me online and look at a whole load of random Raspberry Pi projects that try and make database and big data subjects interesting, then check out my website. And also I'm on Twitter, and it's in my world, it's still called Twitter, and it's always going to be. I did unfortunately make a mistake about 13 years ago when I registered for Twitter, and for some reason put an underscore in my handle, which I don't do anywhere else. So I'm basically Simon Prickett, no punctuation everywhere, so GitHub, whatever. But the easy thing is go to the website. So what is CrateDB? This is a sort of slide of what is it in one sentence? So it's a database. It's open source, which is an important thing to note here. So you can grab it and compile it for yourself. It's written in Java, or you can grab a jar file of it, or you can get it from Docker, or you can run it in the cloud. We provide a cloud service for that has a free tier that we'll be using here today. And it's a database that it can be a general purpose database, but it has a focus on real-time analytics and on what we call hybrid search, which is a mix of searching for things by SQL clauses, where something is greater than 10, as well as searching for things by sort of what we're now thinking of as more traditional Lucene indexes, so keyword matching type searches, and what you would also now call vector similarity search. So run something through an AI model, generate what's called embeddings, which is a huge array of numbers that describe the properties of, say, a textual document, or a series of numbers if you're looking at machine data, or an image or video or whatever it is. Describes the properties of those in different dimensions that the model has been trained to understand. And we'll look at a little bit of that at the end, but that's not really the focus for today. So what can you do with CrateDB? You can basically put all sorts of different things in there. So it's a class of database that you could think of as a multi-model database. Usually databases that involve relational data, so schema-based and SQL-based databases, do not necessarily handle semi or unstructured data well. And then you might start looking at other sorts of databases that do that well. So say a sort of MongoDB or a Firebase or something like that, if you're looking at JSON type documents. And then those don't tend to do SQL or other things well. So if you've got a lot of time series data, you might start to look at, say, Influx or QuestDB or something like that. CrateDB aims to be good at all of these things and to have them all accessible through SQL. So you can put all of your stuff in one place, and then you can get what we say is a sort of path to quick insights into this data by combining all of that different stuff with SQL. So we'll start with some fairly simple examples, and we'll put some temperature and humidity in. And someone had a DHT11 earlier. We've got one of those, so we'll be using one of those. And then I'll show you some more complicated examples from a different data set where we can, for example, look at things that are occurring in a certain geo range, and also have different properties, or even look at things that have a semantic similarity to other things. So this might sound like a lot of new, but it's also a lot of familiar. So CrateDB supports the Postgres wire protocol. What does that actually mean? It means that if you're already using a driver or a framework or a tool that understands and can connect to Postgres, the chances are you'll be able to swap that out, connect it to CrateDB, and then do all of these extra things through the same tool. It also has an incredibly flexible schema. So we'll see what that means, but you can define some table schema. So you can say that table records are going to have this row and it's going to be of that type, and this other row is going to, sorry, this other column is going to be of this other type, and so forth. And you can have the database enforce that, or you can have it be super flexible about, well, if I see a record that looks a bit different from that, what should I do? Should I like add more columns and infer their types? Should I reject it? And so forth. And that includes deeply nested documents. So you could put any old JSON in there, like an API response, and you could fully describe what the structure of that API response needs to look like. The database will validate that and throw out anything that doesn't match. Or you can say, oh, that's dynamic, and we'll just store anything, and the database will figure it out. So what does it look like? This is about as technical as we're going to get with database stuff, and then we're going to actually look at some code. And most of us are application developers. We're not going to build a database. We're going to build things that use a database. So what it looks like at the core is we have all of these different data types. They can be mixed up inside the same database, but also inside the same table in the same database. So if you've got things that logically live together, so for example, if you're modeling libraries, libraries might have a location, which is a lat-long geopoint. They might have an array of opening hours for Monday through Sunday. What hours are they open? They might have a textual description of when the library was built and some information about what the building's like and what facilities you can find in it. They might have some sort of other numerical data about, I don't know, how many books are in there. And they might have some Boolean fields like, does it offer Wi-Fi and is there a photocopier? You could store all of that in a single row in a table and use all of the different data types in there without having to do complicated data modeling. So everything's accessible through SQL, but this is a database that's also good at what you might have heard described as NoSQL topics. So when people hear NoSQL, they usually literally hear NoSQL. So I'm telling you everything is SQL. What do we mean by SQL? We mean not only SQL. So you can access everything through SQL here, but there's data types that you would not normally expect, and extensions to SQL, so sort of a dialect, that allow you to get into, for example, deeply into JSON documents and perform full text searches. So this is what it looks like. It's available kind of anywhere. So why is this an IoT? Why is this good for IoT? Couple of reasons. You can run it on the edge. So you could run it on like a regular Raspberry Pi 4 or 5 as a sort of gateway database that stores things on, say, a site and talks to a cloud. You can run it in the cloud. You can run a big cluster of it on premises yourself. And you can mix and match all of those in like a hybrid configuration. It's also optimized for workloads that have a lot of ingestion. So data that's constantly arriving and changing. So streaming data is commonly found in IoT. We'll look at the classic sort of temperature humidity example here, where when does temperature and humidity data end? Well, never, as long as there's still a planet to record them from. And those data structures, you're not going to necessarily get to a point where you're like, okay, that's the end of that. We'll do some batch processing. So you need to be able to do real-time analytics. So everything in CrateDB is indexed as well. Everything you put in there, including deeply nested JSON documents, it's going to index everything. You can turn that off if you don't want it to do that. But by default, that means that all of your queries are going to be very fast. This is also good for IoT type projects because they're usually sort of bleeding edge projects where you don't know what sort of insights you want to get from the data until you've got the data. And then you don't want to be running queries on, say, a production database that slows it down a lot. So everything gets indexed, everything will be fast, and you can deal with the changing schema. So in short, why is this a good database for IoT? It covers all sorts of data, so structured stuff, so things that you can describe a schema for. Semi-structured, where you can be like, well, this is an object and we know some of the fields. And then totally unstructured, which can be essentially, this is a JSON object that has any schema, or sometimes we might have sensors that have other values that we didn't know about when we designed the database, and we can just start receiving those and work with them. And fast ingestion. A database is only as good as, once you've got everything in there, you kind of want to do two things with it. You want to make sure you don't lose it, and that you can actually query it. Because if you can't query it, or you can't query it for a while because the database is off indexing it, then all the time that you can't query something that's recently landed in your database is a time that you can't get any insights from it. So your sort of concept of real time becomes slower and slower. So we index everything by default, and the database is optimized for things that IoT use cases want to do. So aggregations, for example, the value of an individual temperature, humidity, or a sensor reading on its own, very, very low. But the value of loads of them and a trend is quite high. So quite often you're not interested in the data point itself. We don't really care what the temperature was at 12:01 exactly. Sometimes you do. So I used to work in the food industry, and if you have a handling issue and something goes out of temperature, you do care about that. But usually you care about, for example, what's the temperature drift after someone turns the air conditioning on? How long is it going to take to get down to the target? How much energy do we use? And individual data points in that curve are not really important. Then finally, what might you use this for? So we see people using it a lot for real-time or near real-time analytics. We have customers that use it for video streaming information. We have customers that use it for warehouse management. So the company that puts Red Bull in cans, for example, use this to monitor the process of putting Red Bull in cans, which is a fairly large industrial operation. We also have customers who make the equipment that runs the warehouse that use it to monitor that equipment. So you might get a series of values out of a piece of equipment, like a conveyor belt or something. And then you might choose to use something like vector similarity and take those values, run them through a model that understands these things, and then say, does this compare to a scenario that's eventually going to result in a fail soon? The bearing on the conveyor belt is going to go bad at some point. So we need to take it out and predictively maintain it. It's also a database that gets used a lot for digital twins. So essentially simulating a large piece of hardware or industrial process and running it through different scenarios, stress testing it, trying to understand, for example, what the seasonal workload at Christmas might look like on your home shopping warehouse. So something like that. Where does it fit into the world of things? So because of using the Postgres protocol, generally everywhere that you can use a Postgres tool, you're going to be able to connect to CrateDB or use a driver or use like an entity framework for the language that you're working in, or SQL Alchemy for Python, or whatever it is you're using. And we'll look at some simple examples with Grafana, but it fits into a wide ecosystem of things. And what it's really, really good at is being a singular store for all of these different types of data. So you can run queries that you might feed into training a model, or you might use in some sort of what's called a RAG scenario. So like a sort of AI enhanced chatbot, ask questions about your data and run the results through an LLM like an OpenAI ChatGPT and get an actual real world response back. It's very good at filtering and aggregating that data to feed into those things. So with that said, let's sort of move along to, we're probably all more in the application development area here. So we're kind of interested in how do you get data into and out of a database? Because if you can't do that, then none of these other things are going to be possible. So we have two ways of getting data into and out of a Crate database. So first one is Postgres protocol. So again, if you're using tools that understand that, so anything from PG-SQL command line to most common software drivers for Postgres, or visualization tools, sort of Power BIs or Grafana, they're going to talk to that. Then what we're going to focus in on today, and also hopefully what we're going to see today, is generally useful for people who want to connect to things from a Raspberry Pi Pico or a MicroPython device, whether it's CrateDB or something else, is there's an HTTP port, which is, as you might expect, you can post things into that HTTP port and it acts like a sort of REST API. So you can say, I want to run this sort of SQL, and that SQL might push something into the database. It might get something out of the database, and you'll get a response back. This is very, very easy to integrate things with, and it works quite well with IoT devices because it's sessionless. So what that means is, if your little Raspberry Pi Pico, which has the capability to go into a deep sleep until something happens, suddenly receives like a press on the doorbell or whatever it's connected to, the whole machine can wake up, start the network stack, and go, there's a ping to the database with this event that happened. There's a whole question here about, should you have devices talking to databases directly, or should you put something like MQTT in the middle? So we fit inside that model as well. But what I'm showing here, because I'm developer relations and we want to show the world of the possible, is you can talk directly to the database from anything, which may be very handy in certain circumstances. Do I think you would use talking to the database directly to build an industrial scale architecture? Probably not. You would decouple more and talk to an MQTT broker or Kafka or some other streaming solution, which would then store things in the database. And how would it do that? Well, all of those things are Postgres compatible, so you would just use the Postgres connector. So with that said, what are we going to look at today? We're going to look at some sensors with MicroPython. Again, hopefully this is generally useful information, whether you're going to use CrateDB or something else. You could talk to any API that's out there on the internet and get data. That's quite a common thing. The device down the bottom there is a little Pimoroni Enviro Plus. I've got one here. It has a Pico W on the back. And Pimoroni have been great at producing these sorts of devices that have displays on them. So you can pull data from the internet or your home hub or whatever you want. And here's another one that different sort of display. And they've done a great job of standardizing the library for drawing on those displays. So if you can learn about how to write something on like this guy here, which is a little LCD display, then that same knowledge transfers in MicroPython exactly to their e-ink badges, which are a lot slower to update and they don't have any colors, but the methods and the SDK for building out things are the same. So it opens up a whole world of possibilities once you've mastered this. So we'll be getting sensor data with MicroPython, and we'll be pushing it into a database through an HTTP request, and then we'll sort of see what happens. So with all of that preamble, I'll just have a drink. And this isn't a sales presentation. It's not death by PowerPoint. So that's pretty much the last of the slides. So we're actually going to do something. And I kind of believe in living dangerously with these things. So we are going to do something that starts with nothing. So we're going to start with an empty database table. I have gone ahead and created a database cluster. So I've created a database cluster here in the cloud. That cost me nothing. We have an 8 gig storage free plan. And what you do is you sign up for that and you tell us where you want the database to live. So it can live in Azure or Google Cloud or AWS, and you tell us which region you want it to live. So generally a good idea to have your database living near your code. So if you're deploying code as like Azure functions, put it in Azure and put the database in the same region as your functions if you can. Here I've got, I think it's on AWS in Ireland, but that doesn't actually affect anything. And we're going to talk to it directly from a load of equipment that is sat on the desk here. So there's a second camera here looking at the equipment that is going to like wander in and out of focus a little bit. But so what we've got here is absolutely nothing. And I said CrateDB is a relational type database and it uses SQL. So we have to create a table, and we're going to give the table some level of schema. So we're going to say we just want a table. We're going to call it sensor readings, so really generic. And we'll say every sensor is going to have an ID. And for now, the only parameter we're going to store is the temperature, which is a double precision number, so a floating point number. The other things we're going to do is store a timestamp, so when the sample hit the database, I'm going to have the database generate that, because these little devices generally don't have a real-time clock. So we'll take the database time as the time of the observation. There'll obviously be in a real-world system some lag between the observation being taken and the network and so forth, so a little bit of latency, but that's good enough for this. And this sort of table could just grow forever and ever and ever, which becomes a problem in the database world because it gets very, very big. And then when you want to ask questions of the table, like what happened last week, it has to potentially sort through all of these records to figure out what last week even means. So what I'm doing here is using a feature of CrateDB where we're saying we're going to partition the table, so build little tables that make a big virtual table, and we're going to partition them as month, and we're going to have the database generate a month timestamp, which is essentially take the timestamp from now, rewind it to the start of the month, and call it, in this case, it'll be the 1st of October, 2024 at midnight. So we can then, when we write queries, the database engine knows to optimize which partitions it looks in, because if we're asking things about November, it doesn't need to look in the October partition. So what I'll do is go ahead and create that. And we've now got a table. So if I then do something like select star from sensor readings, as you might expect, there's absolutely nothing in there. So we've got a table that contains a sensor ID, a couple of generated columns, and a temperature. So we're kind of all set with that. So what I was going to do next was demonstrate using a Raspberry Pi Pico and different ways of getting data into here. But I was actually going to start a little bit further away from that and start with just some raw HTTP requests. So if you're not familiar with this, this is a tool called Postman. And what it does is it simulates HTTP requests over and above the simple GET requests you can do with the browser. So here we're doing what's called a post request, which usually means we're going to send something into a URL. and we're going to provide some sort of body, some sort of document, and the thing listening to the URL is going to do something with it and reply to us. So here I'm saying, let's go talk to my CrateDB cluster. It's on port 4200 on this server on AWS. And it's got an endpoint called _SQL, which is the thing that understands SQL statements. And we're just going to send it in a SQL statement. So select everything from sensor readings, what I just did there in the console. And what you'll see is we get back some columns. So the names of the columns that are in the table. And we get absolutely 0 rows because there was nothing in there. So we could then use this to build our own front end or our own display that displays this information. Similarly, if I want to put something into the database, I can, there we go. I can send it a SQL statement inside the post body that actually does that. So here's an insert statement. It's going to insert into sensor ID and temperatures, a sensor ID with all the zeros, and 12.9 degrees. So if we do that, what we'll see when we pull this back up is that affected 1 row. So hopefully we've got a row in the database now. And we can then either go back to here and run this again. And you'll see I've now got a sensor ID and I've got the temperature that I provided. But I've also got these 2 things that the server created for me. So it created the timestamp of when this actually happened. So 6:36 p.m. because it's UTC. So it's an hour off what we are doing British summertime. And then here it's rewound the month to the start of October. So if we want to partition this by month, which we have done, then the database knows, oh yeah, this is an October record. This helps us optimize and manage the data. It also helps us remove it when it's time to get rid of some things. So we can just be like, oh, delete the whole October 2024 petition in like a year's time, or push it out to slower storage or whatever we want to do. We've got a very, very basic post request there that's sending some stuff into the database. That's not normally how we're going to do things. We're not going to sit and press buttons. We're going to want to write some code. So if we swap over to look at some MicroPython code here, I've got a few MicroPython examples that run on, they're all running on different Raspberry Pi Pico W setups with different things attached. So let's first have a look at this one. So somebody earlier had a DHT11 temperature and humidity sensor. If we clear the deck down of the stuff that we've got here, this guy here is a DHT11 as well. It's connected to a Raspberry Pi Pico. And are we going to stay in focus? Maybe, I don't know. It's connected to a Raspberry Pi Pico, and it's connected using what's called a Grove board, which is nothing to do with this demo. It's just an easy way of plugging sensors and things into and out of these without having to solder them. So Grove is like a standard connector. This board here provides a number of Grove connectors, and then we've plugged it in, and it's actually connected to one of the pins on the Pi Pico. So if we have a look at, leave that there for a minute. There's nothing visual with this, but I'll leave it up. What we then do is we've got some fairly standard library code from a DHT sensor. So I've just imported a DHT library. We've told it where it's connected. And then if you're not familiar with MicroPython and microcontrollers, there's no operating system here. So we have to write all the code for everything. So we want to connect to a Wi-Fi network, and we want to send an HTTP request, and we want to keep doing that. So we have to write code for all of those things. There's no operating system to say, oh yeah, connect to the Wi-Fi and manage that for me. So we've got some boilerplate code here that standard MicroPython, it connects to a Wi-Fi with an SSID and a password that's in another file that we're not showing here. And once it does that, you've then got to tell the microcontroller everything to do. So basically, the bulk of your code in a microcontroller program is going to be some sort of while true loop, which is basically saying, do this forever. And what you're normally going to be doing is either reading something and doing something with it and then waiting a while and doing the whole thing again, which is what we're doing here. Or if you've got something more like this, which has buttons on it, you're going to be spending forever in a loop going, did they press the button? Did they press the button? And if they did press the button, you're going to do something. You may work with libraries that are more event-based and have what you might know as a callback handler. So when they press the button, run this code. But at the end of the day, with microcontrollers, something's always going to be looping somewhere saying, I need to do something, I need to do something. If your MicroPython program ever stops, the microcontroller just stops doing anything at all because there's nothing else running. It's not like when you finish running a Python program from the shell on a normal computer, it doesn't go back to the shell or PowerShell or the Finder or whatever you launched it from because there's nothing there on the microcontroller. You're running everything. So at a very, very low level, we can mimic what we had in Postman. So we're going to use the library code to read temperature and in this case, humidity as well, information from the sensor. And then we're going to build up a SQL statement that has placeholders for those and put them in. And then we have some code here that is going to use Python's request library, which is an HTTP client. And we're just going to do a post. And we're going to do a post to the database URL, so the URL that I had up in Postman. And we're going to do the same thing of send it a JSON body that's just this statement thing with our SQL in it. What you couldn't see as easily in Postman is we do have to log into the database. So there is actual security here. You know, anybody on the internet can't just post into this URL. So here we're using what's called basic authorization, which is a fairly standard HTTP solution for this. And what you do is you pass in an HTTP header, which is like a bit of metadata about the request. You say, oh yeah, I'm going to pass in some authorization. You tell it you're using basic authorization. And then this is a secret that's in another file, but it's essentially the username, the password for the database, and it's been encoded through a base64 encoder. So it will look like garbage. Base64 encoding is not encryption. So unless you're using an HTTPS URL, don't assume that your password is safe. Here we are, of course, using an HTTPS URL, so this will be encrypted and we're all good. So we're going to send an HTTP request in every time we read the sensor, and we're going to get a response back, and the response will look a bit like what we had in Postman here. It'll have this row count thing. And if we've inserted something into the database, we would expect one row to have been affected. So we're just going to check for, did we insert something into the database? And we're going to say, yes, we did. And that's all good. So what I'll do now is not very great. Not much will change here, but I'm going to plug this in, which will power it up. It's not actually doing anything at the minute because I've not copied this script to the device on purpose. So what we're going to do is run this script from Thonny on that device. So let's just reconnect. We're connected to the device. And what we can do here is just hit play. And what you'll see in the bottom is it's connecting to the Wi-Fi. So the device is having to connect to the Wi-Fi itself. It's got an IP address there, ends in 249. And it read the sensor and it inserted something into the database. And what it's now doing is it's gone to sleep for 10 seconds. And there it goes again. It's done it again and again. So if we go back to the database console here, what we would hopefully have now is, let's also do order by timestamp is sending. So we get the newest stuff first. So what we've now got is, we've got data coming from the Raspberry Pi into there. We've not had to do anything really CrateDB specific. This is just HTTP stuff. So if you were using an API and you wanted to get data out of something, or you had an API that you could push data into things, then this sort of simple boilerplate code that is pretty much just this, get a URL and whatever authorization your API needs and push your document in there, is going to work on anything. So someone was saying that they might want to do a ServiceNow project with a REST API. This is pretty much the level of code that you need for that, and it will work with anything. So what I'm going to do is stop that. And you'll see when we read this here, so the DHT11, this sensor actually brings back two things. It brings back a temperature and a humidity that we're currently just throwing away. We're not doing anything with it. So what we can do is change this a little bit and put in that is called humid. Change our SQL statement here, and let's call it humidity here. So what we're doing here is I'm actually changing the SQL statement on the device to put something else into the database. And you might expect this to blow up an error because the table doesn't look like that. There's nothing in there for humidity. But we did tell the database that it was a dynamic schema table. So this is where live demos get interesting. Let's run this again. And you'll see it's initially read some dud values because I guess the sensor was initializing. So let's give it 10 seconds to do something real. But it hasn't errored. It's put those zeros into the database. And now we're starting to get real values. So humidity of 63% here in the office, and it's 25.6 Celsius. It's quite warm this evening. So it's off doing that. And if we go look at this, well, what's happened here is we've now got this extra column called humidity, and the database has inferred that it should be a big integer because it's seeing integer values of it. And then what happens to the older records that didn't have that? Well, they all get nulls because we can't retrospectively make up a humidity value. So where CrateDB can be fun for this is it will build the schema like this for you as you go along. And this enables you to iterate on a project very quickly, but also to deal with things from potentially unknown sensor types or things that occur later in a project. You can also tell it we don't want this sort of behavior and it should reject those records. So there is another danger of someone might put a very, very wide record in here and then they're starting to chew through your database storage. So you can tell it not to do that. So you can have just enough schema. So we've now got some records coming in that are temperature and humidity. Not a lot going on here. I could put my finger on there and it would eventually change the numbers, but you get the idea. So we've got those. What happens if we do something completely different? So we've got some different types of sensor going on here. So let's go back to that's in focus and everything. The temperature and humidity sensor. I've actually got a whole desk full of this stuff. So over here, there's another Grove setup. Let's remove this one because we don't need that. Over here, there's another Grove setup, and it's got two things attached to it. There's a light and an audio sensor. So what I'm going to do is plug that in so we can start to see how these start to affect things. And USB-C would be so much better because you can't get it the wrong way up. Pico 2 has USB-C, but it doesn't yet have Wi-Fi, which you do. At some point, there'll be one that has all the things. We've got a couple of sensors here. We've got a noise sensor and a light sensor. And I've got a sample script over here that demonstrates how to use those. So if we look at this, we've got a main here. I'm going to close this because having too many things called main.py open gets really confusing really quick. So here we've got a sound and a light sensor. These are slightly different from the previous sensor. They use analog to digital converter pins straight on the Pi. So there's no library code here. It's just a very simple thing. And then I'm no longer going to make an HTTP request like we did before. I'm going to use something called MicroCrate, which is a brand new driver for CrateDB. By brand new, like I started writing this at 9 o'clock on Monday for this talk, because as a database company, we don't expect you to know the ins and outs of the low level of how that HTTP works. So I started with that on purpose because it's universally useful for learning lots of other things. But realistically, when you work with a database, you would expect to use a driver or something that hides some of these things from you. So here, instead of having a low-level HTTP request, I'm creating an instance of the CrateDB driver, and I'm telling it where my database lives, host, username, and password. It's going to deal with the encoding and the authentication for me. And then once I've got a network connection, which we still have to do because it's still a microcontroller, then I'm basically going to read some sensors. But each of these sensors is a very basic thing. It just returns a number. There's a number of lux or the number of whatever the, I don't think it's decibels, but whatever the sound is measured in by this particular sensor. And then instead of building an HTTP statement and dealing with that, we're just going to use the crate driver and basically say, I want to insert something into sensor readings, and I'm going to have columns called sensor ID, light, and sound. And if you're familiar with desktop SQL, this is a parameterized query. So you say the values for these are things that will follow, and then the first question mark will be whatever the value of sensor ID is. The second one will be light, and the third one will be sound. And then similarly, we'll get a thing back saying, oh, was it inserted into CrateDB or not? So the driver handles the HTTP for us. It also handles some error cases, like if you just made a mistake in your SQL here, it will give you a more meaningful error back than just some HTTP code. It will actually tell you, you made an error in your SQL. So here we've got, if you notice here, this is referring to, again, different columns. There's no temperature or humidity this time. So if we go ahead and connect to MicroPython on here and run this script, you can expect to see, again, it's going to connect to the Wi-Fi. It generally takes a minute when it's doing this from cold. It's got its own unique IP address that was different from the other Pico. And it's stored some light and sound information. And after 10 seconds, it's going to do it again. I think the sound is extremely, that's me clicking my fingers near it, but you have to wait until it comes around and actually measures the sound. The sound doesn't pick up from very far away. So the fact it's 0 doesn't mean it's not working. It just means I'm not making sound at the right time near enough to it. I can cover the light sensor and probably reduce that number. Ooh, no, I can affect the Pi and turn it off and break everything. There we go. Let's run that again. Cables, they're really finicky.
Live demos.
Yeah, well, it's real. It proves it's real. So it's off connecting to the Wi-Fi again, and there we go. We've got some values, and if I keep that covered up, it'll come around again in 10 seconds, and you'll see that there's significantly lower value for light now. So that's not in itself hugely interesting, but let's see what's going on in here. So now we have some other things going on here. So we have temp, humidity, light, and sound. And no one sensor has got all 4 of these, or no one Pico has all 4 of these attached to it. It could do. So you see we've got some nulls in the other areas. So again, we've expanded the schema a little bit based on stuff coming in from the device, which is, you know, kind of interesting thing to have going on. So we're going to take this a little bit further, and without getting too repetitive, we've got another type of device that's got a little bit more going on. So rather than these sort of fairly bare metal Picos, we've got the Enviro Plus here, which is a Pimeroni device. It's got a screen on it. It's got some buttons. It's got sensors. It's got, you bring your own Pico W, plug it in the back. So if we fire this up, again, the propensity for these cables to turn around is almost 100%. There we go. We fire this up, we'll see it gets a really green light, and also it doesn't want to sit like that. So One of my tips, if you do enough IoT demos, is the best tool in your IoT toolkit is actually BlueTack. So what we'll do is BlueTack it to the desk so that it doesn't try and run away all the time and turn over on itself. And we'll see it doing something in a minute. So this Pimoroni device here actually comes with some library support that they provide. So the code here is going to look a little bit more complicated because it's doing a bit more. But let's take a quick look at that. So again, I'm using the brand new Crate driver, so we can connect to Crate by providing some simple things. You could also be running this on your local network and just give it an IP address of wherever you're running it. So if you were running Crate on a Pi and you were then collating information there and using the Pi to make some sort of decision with some other information the Pi could have access to, then talk to the cloud, you might use an IP address or a local host name. There's a lot of Pimoroni stuff going on up here, which is their standard library for things. But basically, we have the similar preamble of we've got to connect to the network. And in this case, we've got a display. It's not the focus of this talk, but if you want to play around with devices that use MicroPython and have displays, then the Pimoroni ones are great because they came up with this Pico graphics library and it runs on all of them. So the display could be something like this thing here, which is just an LED matrix, or it could be what we've got there, which is an LCD, or it could be one of these, which is a super slow e-ink. So yeah, we've all got Pimoroni stuff. But the API for them works the same. It deals with pens and drawing objects, and those objects might be lines on the screen, or there might be a string of LEDs. Similarly, they've got some nice standardizations for dealing with things like buttons and the sensors on the device. So this has got a whole load of sensors, including a microphone and some sort of gas sensor and a light sensor. This is Pico graphics stuff for drawing on the screen. Again, if you want to play with this stuff and you want to play with a range of devices, invest in learning some Pico graphics. It's fairly simple and it applies to lots of things. But basically what we're going to do is a similar sort of thing. We're going to have a loop. We're going to read all of these sensors. And these ones are a little bit more advanced. So Pimoroni's example code accounts for things like the heat given off by their screen, and it offsets the temperature accordingly. That's not something we need to worry about here. But we're going to record a few bits of information and send it into CrateDB in basically the same way that we have been with everything else. And there is a sort of new step here that I'll come to in a minute, but let's just try this out first. So hopefully we've got a REPL on here. So when we run this, what we'll see is this is connecting to the Wi-Fi. If I bring the camera back up here, what you'll see is this actually outputs some stuff on the device here. So it's kind of hard to keep this in focus because it becomes really bright. But it's telling us that it last sent some data 7, 8, 9, 10 seconds ago, and then eventually it's going to do it again. So we can see under here the data that it sent. So it sent, or it recorded these values. It sent some of them. And we can see in here that we've got another record here. So now we've got a temperature, we've got humidity, a light, and a different sort of sound reading because it's a different sensor. So might have different range of outputs to the other one. We might want to normalize those at some point in a query so that we had, like a 0 to 100% of what loud is. But these are just the raw values. So it's off doing that. It's done a couple of those. I'm going to stop it. So what it's sending at the minute is the sensor ID, the temperature, humidity, the light, and the sound. But it also gathered pressure and gas. And we're not doing anything with pressure and gas at the minute. So what I did here is put those in a Python dictionary, which is like an object. And we've called that others. So what we want to do is send that in as well and see what happens. So if we modify our SQL statement to others here, and we need to put another placeholder in there, and then under here, we can put others. Then, so what's different about this, right? So these are all sort of basic types. They're strings and numbers. So we got strings and numbers in the database and everything's flat. This one here's a dictionary. So it has these two keys in it. It could have arbitrary structure with some other stuff in there that could have all sorts of levels of nesting. And the database hasn't got a clue what this is yet because it's never seen one of these before. So if we run this, and hopefully this doesn't screw up my SQL skills in real life, let's see what happens. It's gone ahead and, what has it done? It's connected to the Wi-Fi, it's done that. What is it doing?
I think you're not printing out the others option in your console.
Yeah, I'd have. Oh, hang on. Sorry. I'm looking for the console to show me it's sent the data. It's on the screen in this one, isn't it? So what it's doing is actually working fine. So yeah, the console moved to the screen here as an example because we put the screen. So it's doing that. So what happens over here now is when I execute this, what you'll see is now we've got a couple of records that have this other thing, and it's an object. So others is an object. If we look inside the object, we get gas and pressure. Why is this interesting? Well, because in a SQL database, this sort of stuff normally doesn't happen. You would normally use a document database, like say MongoDB or Firebase or something. And in a JSON extension to a SQL DB, you wouldn't get the feature where if you wanted to write a query that used, select whatever from a time range where the gas value is greater than 63,000, that might be very slow because it might result in a table scan. This CrateDB will index everything by default. So this, now it's started to see this, it's creating an index for them. It'll create a column of storage for it, and it will be extremely fast to query it. So this is very good for projects where you kind of like don't know what the shape of the data is, and you don't know what the sort of queries people will ask of it are. And you don't want to keep going back to, say, a DBA or somebody all the time and be like, can I have another index on this, that, and the other? And can I have an index on a deep thing? Or do I need to flatten this out to index it? So in theory, and we're going sort of slightly beyond here, so we should also be able to put some other stuff in here like location, and this is where I'm a node person. I just want to write JSON here. So if we do something like this and put in location name and call it office, and then like location phone number and call it, I don't know, good old Nottingham number 0115 1234 567. You probably wouldn't put this in every single observation. What you do is put this in some sort of metadata table and do a join on it, which the product totally supports. But we'll need a comma there as well. But the aim of doing this will be just to show in a simple little way that when we get all of these things up and running, we should now execute this, and the object here has now got a sub-object inside it. And it probably won't surprise you at this point to know that these things are also indexed. And I can also query them. So if I wanted to do something like where others, location, name equals office, then I only get back the ones that have that value. And it was reasonably quick, and it still would be if we had loads and loads of records, because it's not going to table scan it. It's got an index for them. If you're not familiar with data or relational databases, avoiding table scans is a good thing. Anything where it's a table scan, it has to look at every single record in the table to figure out what's going on. So that is sort of what I've got with sensors, I also said earlier that, so we did all of this through an HTTP interface, which basically means, as we saw at the start, you can interface with anything. Almost everything nowadays has got some sort of networking stack and some sort of HTTP. So you can interface with anything like that. We also support the Postgres protocol. So you don't have to, for example, go and invent some wheels. So I've got a table over here called weather data that's actually got, let's see how many things are in it. Does that count from weather data? There are 174,098 things in there. So quite a lot of data. And you're going to want to use standard tools. So here's a graph in Grafana of that weather data table for one of the weather stations. So this data actually comes from Chicago. It's from a course that I built about this product, and it's open data. There's several years worth of data. How do you configure this in Grafana? Well, if we just do edit here, what you'll see is I've got a data source called CrateDB Cloud, but if you're familiar with Postgres, that's the Postgres elephant there. So it shows up as just a Postgres database. You tell it where to find that cloud database. And then you just either use the query builder and pick from columns and criteria and so forth, or you write your own query in here. So you can do any sort of aggregations or whatever. And here from Grafana, you could start using, say, their alerting mechanism and things to be like, I want to build something that puts my office temperature in and alerts me when it goes above a certain thing or stays above a certain thing or whatever. Then going back to that, we also have data in the demo database that I've got here. Again, from the city of Chicago, we have something about 311 calls in Chicago, which is, if you're a citizen, you put non-emergency things in, like the street lamp's broken or whatever, then you put in a 311 call. There's a schema here for the type of call and information about it, where it was located and all of that. This has got an object in there. It's got geodata in there. And here on the dashboard, with a fairly simple query, we can plot all of these on a map. So if you've got sensors or things that are moving around or have positions, you've got lots of buildings and you're storing temperature in them or different locations in your area, then it's very, very easy to use tools like this with the database to generate a map. So this is a map of streetlight issues in Chicago that haven't been fixed yet based on that open data. And again, it's just a Postgres query. So we're pulling the latitude and longitude out of an object in CrateDB, and we're filtering by, it needs to be a streetlight out complaint and the status needs to be open. So you could build yourself a nice dashboard with your home data or whatever data you've got and use maps, bar charts, alerting, all of that stuff. And that was about what I got. So generally with a developer relations talk, I sort of try and leave people with one thing. So if we go back to wherever that was, wherever we left off, so show me some code. Ooh, that's not the right presentation, is it? What happened then? That's better. Let's use the right presentation. So if we went to back to where we left off, if I could ask you to take one thing from talking to me, it would be go and learn some more. We have an online course that is free, and you can learn a lot about CrateDB on this course. You can also learn a fair amount about different types of SQL queries. So if you want to learn about SQL, the standard query and data ingestion language for many databases, you can learn about that. And you can also get a certificate of completion and put it on your LinkedIn profile. So if you want a qualification for LinkedIn, you can answer a few multiple choice questions about the content and so on. And this is a very hands-on course. So you get set up with your own database cluster in the cloud, which is free. you load in lots of data about the city of Chicago. So things about taxi rides and 311 calls, so things like those. The street light is broken type issues and all of that stuff. And you do a lot of geospatial stuff with a map. So, find me, for example, certain types of 311 calls like aircraft noise complaints. Where are they located on a map? You plot them on a map. You notice that they tend to be located across the flight paths, going into and out of the airports. And this course also covers things that I talked about earlier, like using search for both keywords and vector similarity. So you can, for example, search for, imagine you're moving to the city and the data set's got some information about each neighborhood. So, description of what historically the neighborhood was about and who lives there and what sort of facilities there are. And you can basically say, I like this neighborhood. Find me things that are, keyword match similar to that. So they have keywords that look the same, or find me things that are more semantically similar to that. So talk about the same topics. So for example, you could ask it questions like, in a semantic search, find me neighborhoods that have European immigrants, and it will understand that Italian and French and British and German are all European things. Whereas a more simple keyword search wouldn't, because it doesn't, unless you have some sort of synonym set up, understand that European is composed of all of these things. So yeah, I would encourage you to go check it out. The cost of all of this is absolutely nothing. It's basically your time. So please do play around with the product. And if you get stuck, we have an online community. It's a discourse forum, so you can post stuff up. Or also, I'm fairly easy to find on, generally on the internet. You can find me and chat to me and ask me questions. So that was about everything I got. I'll stop the slideshow and just keep the share open in case anybody had anything that they wanted to generally see or look at.
That was really good. Thank you very much. Cheers. Really enjoyed that. I had no idea that CrateDB did vector storage as well. Is that relatively new, or has it been doing that for a while?
It's I think it was we're about to release 5.9 and it was in 5 point something, so
Yeah.
relatively new. I can I've got some Jupyter notebooks here. So what we can do is steal, there we go. I've exposed a password on the internet, but this is a throwaway cluster, so it doesn't matter. It'll be gone by tomorrow.
But is it now?
So what we can do is, for example, I've got a Jupyter notebook here and I'm just stealing that information. So I need to associate it with this database. Let's go. There's a better way of going to the top. I can't see the scroll bar. There we go. So if I just replace this placeholder here with that, and we go ahead and run this, what we'll see is, so a couple of things. I'm just going to create a table here, and yeah, a couple of interesting things with CrateDB as well that sort of come out of this question is you can load data sets using a copy from SQL command. So we've got the data set in GitHub. So this is actually just going to copy a CSV file from GitHub and just bulk insert all the records. So
that's a bit good. I like that.
That's brilliant.
That also means you can put your data somewhere on the internet, like on your own website or whatever you want. So we loaded that.
Obviously, with whatever risk you want to take by doing that.
Yeah, it might be that it's public data, so it's great for. We have a sample data sets repo that people can use for things. So, for example, we can do things like we can do what's called a I forget what it's called, but whatever the algorithm Lucene uses for keyword matching. So we can do some basic, simple keyword matching and say, find me some community areas that match railway. And it would be useful if I actually ran the preamble things to declare all of the variables that Python is going to use here. So let's skip ahead. So we can try and match things that match railroad and historic, and you're going to get some results back where the community description talks about railroad and historic. And that's great. And it has some level of limitation, like you can configure slop for, slight misspellings and other things like that. So skipping down from that, you can also then, obviously, because it's a SQL database, combine these with things. So let's find things that are university but spelt slightly wrong. That won't do anything until we give it a fuzziness factor of, well, how wrong is acceptable?
Okay.
And then you can ask it things like, well, okay, find university with a bit of fuzziness factor, and I'm only interested in communities that have more than 30,000 people in them as well. So you can combine different SQL predicates that talk about totally different types of search query. And then, going all the way down to here. So here are some vectors that I generated with OpenAI's large text model that represent the descriptions of the neighborhoods. Here's a query that basically says which neighborhoods are associated with European immigrants, and that's been vectorized into a very big 2048 dimension vector. And then what we're going to do is here we can say to it, well, okay, I want community areas where the nearest neighbor match between this vector field that happens to be inside an object in the database, and it could be deeply nested in an object, doesn't matter. Has minimal distance between my query vector of immigrants. And if you run this, you'll see that what you get back, for example, as I was saying, is we asked it about European immigrants, and this one hits highly because it talks about all of these nationalities. And it only knows that because the model knew what Europe. So OpenAI's model that generated the embeddings knew what that meant. If you did that with the sort of standard Lucene match search, it would miss that because there's no like misspelling or whatever of Europe that would lead it to that, unless you had manually created a synonym dictionary that said, well, Europe also means this, that, and the other. But then it wouldn't understand that sometimes it doesn't, because geographic Europe and political Europe are different things.
Yeah. Is this Arda embeddings it's using for the OpenAI Arda embeddings, is it? Or probably is. I've got a talk on this, but I do it with AI search, which is a reasonably expensive service. So this sounds interesting.
I think I just used text embedding large.
Yeah. Oh, okay.
And the API and a little Python program to do this. But you could obviously, because we play nicely with Postgres and stuff, you could also put this into a LangChain thing and say, go get this from the database, embed it, and so on. And that's how vectors work. The other sort of semi-interesting thing is the geospatial's quite fun and also useful with IoT. So if I just come down to somewhere. I don't know. I'm lost in my own. I wrote these.
Yeah, but it wasn't today. Notebook. So
the maps don't show until you run the thing because they're dynamic. So they don't generate a PNG that gets saved. So you can, for example, if you've got some GeoJSON, which you can get off of Google Maps API or anywhere you like, you can basically ask the database questions like, oh, if we've got the geopolygon for the community area or whatever the thing that you're looking at is, you can ask it, well, which things in the database physically intersect with my GeoJSON, or which things are contained by my GeoJSON. And then you can start to write interesting queries like this. Let's see if we can.
You could do geofencing with it in theory, couldn't you?
Yeah, so you can do things like, I'm going to have to start this from the top, but let's just do that. And I think I created all the tables ahead of time for speed.
While you're clicking play, as far as time series data ingestion is concerned, is there a limitation on speed? And I mean both sides of that equation, because obviously ingestion itself, but then when you're writing queries against it, something like Azure Data Explorer, for instance, is awesome because it's like millions of records in less than a second. where's the limitation? Is this a CrateDB thing, or would it just be the infrastructure you deploy it
on? Ultimately, it's going to come down to the infrastructure you deploy it on. So we have customers that are putting in, I think, about like 900,000 records a second in real production use in machines.
Okay.
Broadly, that comes down to the way it scales. So I think I said throughout this, because I need to get good at this, cluster all the time. We've been using a one node cluster, which is still a cluster. In a real scenario, you would scale by just adding more and more cluster nodes, and then the cluster kind of figures out what it wants to do with them.
Okay.
But they can all perform the same roles. So you can put a load balancer in front and spray out all of those HTTP requests to different cluster nodes. The one decision that we took to kind of grease the wheels of that is CrateDB is eventually consistent. So there's no like locking things going on. How fast it'll index things before they're available to query depends on how big your cluster is and how fast things are moving around.
Same as ADX.
But you can get that to essentially near real time by putting more and more stuff in the cluster and then dialing it back again when you don't need it.
Yeah.
And in terms of what you run it on, it runs on commodity hardware if you want to do that, or it's in all of the hyperscaler clouds as well. So
what's the perf like on a Pi? Sorry to interrupt and sorry to take all the questions.
That's all right. You know what? I need to spend some time playing with that. So another level of demo I want to do with this is all the sensors talk to a Pi. The Pi does something that only it can do, like say the AI camera or something, and combines all of that information. And then when something interesting happens, it pings it up to a cloud database, which is quite a realistic scenario. So I worked for a while professionally on a solution that had sensors in every room in a hotel, and then a local Pi 3, it was then, brain. And what that did was it looked at all the aircon and energy consumption in the hotel and fed information to the cloud so it could be aggregated and controlled with other hotels. But when the cloud link was down or flaky, it needed enough of a local database to make some sensible decisions, like in offline mode, if you like. So as a like store and forward and a hybrid solution, it should be pretty good. A lot of our customers work in manufacturing smart factories, and those can't stop when your redundant internet lines all go down. So they do generally work in that model of there's a lot of CrateDB on-premise in places that either talks to the cloud or talks to other premises, but can make local decisions.
Can you have a cluster node on a Pi that's connected to a cluster node in the cloud?
Yeah.
So it would automatically sync. Would it work if it went offline then and came back online? Would that eventual consistency break or?
Don't know how well that would go. This is where I'm like, I'm developer relations. But these are the sorts of things that I should play around with. But yes, in theory, you can split your cluster around lots of different places. You could have a multi-cloud one if you wanted to.
And multiple Pis.
Go figure that yourself. Or like I've got 10 of these guys back here that all have different colored heat sinks. And I do know that Crate works quite nicely on Balena, so you could deploy a Balena fleet. So for people who don't know, Balena is a way of deploying software to Raspberry Pis and other single board computers from a web interface and controlling it and accessing the console and basically managing them without having to go visit the device. It uses its own container mechanism underneath. It's not Docker, it's optimized for Raspberry Pis. I know Mark over there quite well, so I really should do something with him. But sorry, wherever you were with geo stuff, so you can write questions like, get me all of the names and the population, which happens to be in an object, and boundaries here is a GeoJSON field, and plot them on a map. And then obviously, how you want to plot them on the map is up to you. This is leaflet, but it's a really, really simple translation because all you do is, create some GeoJSON with a bit of the result set. You don't have to go digging into that result set and format it because the database has already given you GeoJSON. If you're familiar with geo stuff, it also understands WKT, the other format. well-known text, which is a bit weird of a name because it's only well-known if you know about it. I don't know why they called it that. So yeah, you can see that you can draw, for example, here an area map of all the areas of Chicago with their relative populations. But what's sort of more interesting is, I'll skip over that one, which is a bit of the store finder. If you were to do something like, okay, I'm taking a trip, which is a fairly common one. I lived in the States for a while and I had to go here quite a lot. You go from the Loop, which is the business area downtown, to O'Hare, so you can get out of town. O'Hare's like the massive airport. This is a fairly common trip. So here's a model of that trip that is just represented as a bunch of GeoJSON points. So you can directly ask the database, well, okay, which community areas am I going through? Where you say, again, here's my GeoJSON of my trip. I don't have to do any transforms on it, just throw it the database. And you tell it what field to look in, so the boundaries fields for the community areas. When we run that, we get a list of them, which is kind of dull. But if we do the same query, we can also then join it with some other things. So if I want to know where people have reported lots of road-like issues, so sign repairs, street lights, potholes, they're in another table called 311 calls. We can do joins on that. You know, distributed databases and joins don't always sit well. So Crate does distributed joins. It does them with a distributed engine. So the nodes will all take part in this, and you know, one of them will crash together a result set and send it back to you. But the query is done in parallel. So once we've got that, we can then just color this in and be like, okay, here's my trip. And what the colors now show is where the areas of the most problems with the road that are another table with a completely different type of data are. So we can be like, oh, okay, well, you know, if we're going to get stuck anywhere, it's likely here, just as we leave Chicago because the roads are terrible. And because it has a high ingest rate and a fast index rate, I did a whole talk in Amsterdam about modeling e-scooter management, you know, where you've got people on the scooters want to know where a scooter is nearby that's also got enough battery. And people who are collecting the scooters to charge them want the opposite. They want to know where the scooters are that don't have enough battery. And then you as the operator want to know where do the scooters generally end up and need resettling to so that I make the most money. And it really excels at that sort of problem space where there isn't a like, okay, let's close the business for 5 minutes and work this stuff out. But a good enough snapshot answer from a few seconds ago is continuously good. So, you know, terrible, for example, for building a current account banking application where you do want locking and like actual transactions. Great for this sort of thing.
I like that. It would also tell you, you know, if you wanted to do like ULEZ zone, if you're going to drive through one of those, Google does this for you, of course, but
yeah,
same sort of thing, any zoning like that. I quite like that. That's quite cool.
But yeah, you know, if you've got your let's just no, I don't think there's anything more particularly interesting in here. But yeah, you know, the fact that you can do distributed joins is kind of cool. And if I were to tell you what not to use this for, because I think it's important to do that as well, as like don't use it for anything that needs strong transactions, and don't necessarily, and you know, as a result of that, don't expect to get rollbacks necessarily. So it's very much a sort of operational analytical time series geospatial database. I also think I'll stop sharing at this point. I also think it would be a good choice if you entered yourself into a hackathon, because you don't have to spend a lot of time messing around with choosing tools. Just go with the Postgres ones. You don't have to spend a lot of time having someone iterate on what your data schema is. You can just throw stuff in there like it's a NoSQL database. But you also don't have to spend a lot of time learning a bunch of different query languages for different types of data, because everything's equal. So
I like it.
So yeah, that's us, and that's what we do. I guess
Any
the
other
one thing I didn't
questions?
say is
Yeah,
where does CrateDB come from? It's a company in Austria mostly, but we are very remote.
You mentioned a couple of times that it will work on a Pi, and you've also said it's very for your free version, get onto the cloud and do that. Like, how well does it work on Pis? And for example, if I had Docker running on a Pi, like I've got a Pi 5 waiting to turn up at some point soon. So how easily would I be able to get it on there?
It should be very easy to either run it in Docker, you just pull the container and run it, or if you don't want that additional overhead, it can be run as, you just need some sort of JVM, so Java Virtual Machine. It's a Java product, so anything that can run that and has suitable storage, you should be fine with. I do need to spend some time playing around with it on the Pi. But if you just got one or two, probably just run it directly on the Pi and don't worry about Docker, because you haven't got a whole load of complicated dependencies to install and muck up your operating system.
The only reason I'm thinking Docker is because some of the conversation that we were having before this call started, I think I'm going to have to use Docker for some of the software. So that's the only reason I was thinking Docker for this as well. Get it all running in on the same machine.
Yeah, I guess sort of the only caveat with Docker is you're essentially running a whole other machine with a whole other operating system inside the Docker container, which has a whole load of benefits, but not always the greatest for performance necessarily.
No.
In terms of installing that on on local hardware, so I have got a mini PC, which is the N100 Intel processor. So I presume that there probably would be some options installing that on the existing operating system without containerizing.
Oh yeah, so let me find the Zoom window again and come back to Cheers, guy. So yeah, we have options to install on most things, and really your dependency is, like it says, it's the JVM. Or you can get a bundle from us that has an appropriate JVM built in, and it just runs like an executable. So yeah, if we pick, for example, I don't know, let's pick one I don't really know about. So I don't know very much about Windows. So you're basically going to get a zip file from us, extract it, and run what looks like a binary. And off you go. And also it plays nicely with instrumentation. So because it's JVM, anything that can monitor a JVM type process, it understands how to talk to those.
Yeah, I think one of the things we were talking earlier about kind of weird and wonderful projects. One more thing that I'm quite interested in is the LoRa devices, the low range wave elements, so where the distances are just vast for reporting. So having a microcontroller just collecting data and sending via LoRa method into a device that then would have the database on it would be, and this database would be very suitable. And at the same time, one of the main reasons I like your presentation was just because this is all the code that, not being a developer and all the writing of the code, the MicroPython kind of approach and all the rest that I'm reasonably comfortable with. So that makes me happy.
Yeah. If you can get comfortable with basically you're writing something that lives in a loop and does something with HTTP every time around that loop, and then pulls something from somewhere and combine those two things, you can go a very long way with a very little amount of code. Especially if you just wrap the whole thing in a like sort of try, except I'll just reboot the whole board, it'll be fine, and don't even bother with a lot of error conditions. And then if you find that you've got a sensor that's constantly rebooting, then you've probably got an actual problem rather than a transient one. But
well, I have done, which resonated, one of the things that you mentioned earlier about the RTC element of the microcontrollers. I have actually built a clock with a microcontroller and RTC. I tried to get around the timing elements of it, and in the end, I added the battery.
Yeah, or you could go and like talk to a public
or
network
or
phone
to do
server or
that,
something. But then if you lose the network or you don't have a network, then
oh,
yeah.
there have been many considerations. In the end, it's an offline device with a battery, and it's an actual light clock. So yet again, it comes back to me doing some lights, as we discussed, and I created a clock where a circular 3D printed frame and lit the lights out for each minute and the hour. It's meant to light out, and added P and N button, but I added the or in the middle just for the sake of it.
Yeah, you see people building. So the other thing that I'm sort of known for on the internet is having a big flip dot display out of a bus that isn't here today because I've been recording videos for work, but usually it's behind me. Um, you see people starting to, there's a guy on Twitter who's making binary clocks out of those now. So, you know, the dot has a very bright side and a very dark side, and it's an electromagnet and makes this really nice noise when it clicks. And you just basically control a load of relays through I/O ports. There's some fun clocks out there as well. I'm sure Pete's seen, there's a YouTube channel and a website called Gurgle Apps, which is, I think it's two sisters and a brother, and they make projects. They've got a word clock kit with a Pi Pico, which, you know, it lights up on individual words. So it will say like 5, 2, 2, and they're all in like a crossword matrix. I've got to build that. There's one of those back there.
Yeah, I've not seen that. That looks cool.
Oh,
So it's a little Pimeroni hat for the Raspberry Pi. And when they released this a few years ago, they decided to make a binary clock out of this, which was quite clever because it took a while to work out what time it was.
telling me, yeah.
But it works quite well.
I'm a big fan of like a single purpose display.
Yeah.
And also the mechanical display. So normally the thing that I do with the bus sign is it's normally hooked up to an aircraft ADS-B tracking aerial, which is a free data source if you've got the little software-defined radio. And you store lots and lots of messages about aircraft, and you can eventually work out what they are, and then it puts it up on the sign when it's figured out something like more interesting than a 737's going by. So like the jumbo goes past the house here. We know it's local because it came within radio range of the house, and we know what it is because we've read messages from it. And then you can have all the MQTT based alert screens go berserk when it happens.
That's pretty cool.
Well, one probably you would like. There is an ongoing project, a digital number clock, but with marbles.
Oh yeah, where it drops all the marbles down to make the number.
Yeah, exactly. So the guy has built the hour and the minute. Now he's working out how to build the seconds.
Yeah, because your refresh rate is going to be a big problem.
And that is his biggest problem. He's still working this out. I think he's been on it for about 3 or 4 months so far.
Yeah,
Just the seconds.
I need to finish with the bus sign. I made it play Flappy Bird, so there's an arcade button, and you use one like pixels worth of the bird, and then you shunt all of the pipes along, and it runs at 2 frames a second, which makes it sound really easy because you can see it coming a mile off. But it's like a slow moving tragedy because also if you miss with the bird can't move faster than 2 frames a second either. So you can see the crash coming a long way away, and there's nothing you can do about it. But I do need to finish that and like let people play with it somewhere.
That'd be cool.
Definitely.
Right, I'm going to go and say goodnight to my children. Hopefully they're still awake. But thank you so much for the talk, Simon. That was awesome, and I've learned a whole heap about CrateDB. So
yeah, thanks for
thank you for that. That was really good. And yeah, I'll definitely go check that out. I need to do some stuff with that. I've not spent enough time looking around. I'd like to have more time So if you have a methodology for getting more time, then that's great.
It's sadly not. I've got the 80% finished project file and all of that stuff there.
Yeah, absolutely. And yeah, thanks to folks for coming along.
Yeah,
Again,
thank
if you tweet on the hashtag NotsIoT, there's a very good chance that at least one of you pair will win a JetBrains license. So by all means, do that, and I can drop you one of those across if that's something that interests you as well. So, and then to folks on YouTube, thank you very much. I'm going to